Who's actually going to get the most out of a 5-axis CNC router like this, and who should walk away before they spend a few $1,000s? If you're the kind of maker who dreams about carving aerospace-grade aluminum parts at home, the Ovsuqu steel CNC router might feel like a ticket to the big leagues. If, on the other hand, your projects are limited to hobby-grade wood and plastic, you could end up paying for a level of precision you'll never need. Link is in the description if you want to check the product details on Amazon. Let's break down the real-world considerations that usually get buried behind the headline 2.2 kilowatts motor and 5-axis hype, so you can decide whether the price tag makes sense for a regular workshop. First off, the biggest hesitation people have with any high-axis CNC machine is the learning curve. A 5-axis system isn't just a bigger version of a 3-axis table. You're suddenly dealing with rotation on the axis while the whole head swivels on the axis. In practice, that means you'll spend a good chunk of your first month just learning how to generate the toolpaths in your CAM software, calibrate the harmonic reducers, and get the servo drivers talking to your controller. If you've never touched a multi-axis setup before, expect a steep ramp up. For a seasoned fabricator who already runs a 3-axis mill, the extra 2 axes translate into the ability to machine undercuts and complex contours without refixturing, which can shave hours off a production run. The steel frame is a point that many buyers ask about. In a workshop where you're cutting stainless steel or copper, a rigid chassis matters because any flex can ruin tolerances. The Ovsuqu's all-steel structure does exactly that. It dampens vibration when you're pulling a 12mm cutter through brass at 5m/min. I've seen similar machines on the shop floor where the frame flexes enough that the final cut is a millimeter off. This one stays solid enough that you can trust the dimensions you set in the CAM file. That's a practical strength you'll notice the first time you try a tight-fit gear housing on a prototype. On the flip side, the same steel construction adds weight, and the unit weighs over a ton. Shipping and moving it isn't a weekend DIY project. You'll need a forklift or at least a pallet jack and a clear pathway from the dock to your shop. If you're renting a small garage or a shared makerspace, the footprint, roughly 3m by 4m, can be a deal-breaker. The machine size also means you need a decent power supply. 2.2 kW draws a lot of current, and many home workshops will have to upgrade their breaker to avoid tripping. Those hidden trade-offs often get glossed over in the spec sheet but show up in the first week of ownership. What about the actual cutting capability? The harmonic reducers on the rotary shafts give you finer control over the A and C axes, which is where you'll feel the difference compared with a cheaper belt-driven system. In a real-world scenario, say you're machining a turbine blade from aluminum. The smoother rotation means the cutter stays on the optimal angle longer, reducing tool wear and giving a cleaner surface finish. That's not just marketing fluff. It translates into less downtime changing inserts and a better-looking part straight off the machine. However, the machine's servo motor and driver configuration isn't plug-and-play for everyone. The XYZ linear guides require precise alignment during installation, and if you skip that step, you'll hear a low hum and see the carriage drift over time. In practice, that means you need either a professional installer or a good amount of patience to torque the bolts to the exact spec. For a hobbyist who is comfortable with a drill and a wrench, it could become a frustrating trial-and-error process, especially because the machine doesn't have an intuitive auto-calibration routine. That's a practical weakness that can eat into the time you expected to spend actually milling parts. Now, who should seriously consider buying this? If you're a small-scale production shop that needs to turn out custom metal brackets, aerospace components, or medical device housings in low volumes, the 5-axis capability lets you avoid multiple setups. The precision from the harmonic reducers and the rigidity from the steel frame will help you meet tighter tolerances without investing in a full-scale industrial CNC. Likewise, a university engineering department that wants a versatile teaching platform will benefit from the multi-axis exposure for students. Who should walk away? If your primary material is wood, MDF, or PLA, a 3-axis router will cut your costs dramatically and still give you the flexibility you need. If you're a weekend hobbyist who only needs to make a few decorative metal signs a year, the upfront cost, the need for a robust power circuit, and the space requirement likely outweigh the occasional benefit of 5-axis machining. In those cases, a smaller CNC mill or even a quality CNC plasma cutter might be a smarter investment. Value for money is where the rubber meets the road. The headline price puts this machine in the mid-range of industrial grade.